Hello and welcome to this 3DO webinar preview. This is a small sample of the original presentation, but if you'd like to view the full webinar, please click the link in the description below.
Hey, I'm Matt Sand, president of 3DO, and we are a production metal 3D printing shop, and I'm glad to be presenting to you this webinar today, Metal 3D Printing in MedTech. I'm going to go ahead and share my screen now, and we'll be talking about case studies, success stories, and ultimately what it takes to get to production with this exciting new technology. So let's talk about today's presentation and what we're actually going to cover. We're looking at first a quick intro to metal 3D printing or additive manufacturing. We're going to compare additive manufacturing to traditional manufacturing, and we're going to talk about the benefits of metal additive manufacturing and technology. We'll talk about challenges that are unique to medical device and medical technology companies, and we'll finish with a couple great production success stories leveraging the power of additive manufacturing. So before we dive in, let's just set the stage. First, forget everything you know about plastic 3D printing. When we talk about metals, it's a completely different world. I'll use additive manufacturing a lot, aka AM, or additive manufacturing. And according to me, and you'll see a lot of different subtle definitions of what additive manufacturing is compared to 3D printing, and a lot of people try and pull them apart and separate them, but I'll use them interchangeably. Additive manufacturing is the same as 3D printing, so you can interchange those. And then something that we'll talk about a lot is sintering. When it comes to metal 3D printing, it usually starts with spherical metal powder. And these are very small spheres in the powder. The particle size might be 10 to 50 microns on average. And sintering is what happens when the powder particles fuse together. They sinter together. And if you haven't heard that term before, it can be kind of confusing. But that's what sintering is the idea of taking powder and consolidating it together to make a finished metal part. When we talk about metal additive manufacturing processes, I'll be the first to acknowledge it can be really confusing. And it's confusing because there's so many different processes. You have powder bed fusion, laser sintering, laser melting. You have binder jetting, which is getting a lot of attention recently, but it's actually a pretty old technology. It's been around for over 20 years. You have extrusion, which is an FDM-like process. FDM is very popular in the plastic 3D printing, but it's becoming very popular now in metal 3D printing for prototyping. You have DED, material jetting, and of course intelligent layering is what 3DO calls its own technology, and there's a lot of technology being developed in the background that we'll undoubtedly see come to the fore over the next decade. The bottom line when it comes to metal additive manufacturing technologies, as you can see here, it's really complicated, and this is an eye chart. You're not really meant to be able to read this, but you can see all the different processes and all the different companies that are associated with those different processes. So it can be, when you're the outside looking in and you're just thinking, hey, 3D printing is 3D printing, it can be really kind of intimidating and confusing when you first get into it. So just realize there are different processes of metal 3D printing, and each one has its own pros and cons as you get into it. Great, so let's move on to the next section, which is additive versus traditional manufacturing. And this is kind of interesting to look at, especially from the perspective of economics. How are the economics of additive manufacturing different than traditional manufacturing, and when would you actually implement additive as opposed to traditional? The first question I just want to ask, because I think it's kind of an interesting brain teaser, is where are all the production parts? It's kind of interesting when you think metal 3D printing has been around for 30 plus years. Laser sintering, DMLS type of technologies, they've been around for decades, and yet we don't really see that many metal AM parts in production. And the first point that I think is important to make is when it comes to production, it's very different. Customers think about production versus prototyping very differently. Of course, prototyping is great for one-off production, for product development, for iterating on different designs. But when it comes to production, that is serial, recurring volume production, the thinking is kind of different. And in our experience, working with customers exclusively on production and no prototyping, cost reigns supreme. So when we see the QCDS framework that we're all familiar with, cost really does reign supreme in this equation, because customers in production assume you're going to have quality. They assume you have on-time delivery or better. They assume you have good customer service. So what gets you at the table and keeps you in the game is being cost competitive. At least that's been our experience competing against the traditional manufacturing of CNC machining and metal injection molding. So if cost is so important, let's look at how the economics actually play out in additive manufacturing versus traditional manufacturing, and where additive manufacturing could potentially have an advantage versus traditional manufacturing. The first is tooling. And in the category of upfront cost, tooling would be one of the main costs that traditional manufacturing typically has a lot of upfront expensive costs, whereas additive manufacturing has potentially no upfront costs. Of course, if there's some post-processing requirements and you need to build a fixture to process the parts, then maybe there is some upfront cost, but it's really a fraction of what traditional manufacturing costs, especially when we think about metal injection molding and you actually need a mold and you need to pay as much as $50,000 or $100,000 for the mold to be made. It can be very costly. MOQ is minimum order quantities. So in traditional manufacturing, it's thousands or tens of thousands plus, whereas in additive manufacturing, your minimum order quantity potentially could be one. 3DO's minimum order quantity at this point is about 1,000 pieces per year, or about 100 pieces per month. So that's kind of when we look at production opportunities, moving things into production, that's kind of what we're looking at. But even at the idea of hundreds per month, or for high value applications, it might be tens or dozens per month. It is very different than traditional manufacturing. When it comes to lead times, traditional manufacturing is looking at months to years, whereas additive manufacturing literally could be days. So lead times is pretty game-changing when it comes to the benefits of 3D printing and how you might implement that in production. Of course, ease of innovation with 3D printing is undisputed at this point, versus traditional is very costly and very difficult. Very low, if no material waste. Like FDM is a great example of process where the only material you're putting down is the actual material dedicated to the part. So it could be no material waste, versus medium to high with traditional. Complexity is very costly. I'll show you a cost curve in a minute that shows the more complex a component gets with traditional manufacturing, the more expensive it becomes, whereas with additive manufacturing, complexity doesn't matter as much because we're building parts on a layer by layer basis. And then finally, when we look at quantities, high quantities in traditional manufacturing, typically traditional manufacturing struggles with low to medium quantities, or at the very least, there's a big price premium put on low to medium quantities, whereas the cost curve with additive manufacturing is pretty flat. So I think this is a pretty revealing chart here when we look at cost versus complexity. Cost is on the y-axis and complexity is on the x-axis. As complexity increases, you can see the traditional cost curve is here, and it increases as the complexity increases for the part. And then, of course, if we're looking at very low complex parts, then the cost for traditional manufacturing might be very low. But there's a threshold at which additive manufacturing becomes a much lower cost potentially than traditional manufacturing, because the cost curve for additive manufacturing is flat. So this is where we get the idea that complexity is free. Of course, that's not entirely true, but just as a general rule of thumb, for additive manufacturing, that definitely is the case. Then let's look at cost versus quantity. This is another interesting one where on the x-axis we have quantity, and the cost per part in additive manufacturing is relatively flat. You do see some economies of scale, but not like traditional manufacturing, where you can see the traditional manufacturing curve really kind of falls off a cliff right here. And there's, again, a threshold at which additive manufacturing will just become more costly on a per part basis, but traditional manufacturing at potentially higher volumes could get much lower. What's really exciting to me, and what we're seeing with, say, 3DO's new technology and a lot of other new technologies that are being introduced, this cost curve is actually being shifted to the bottom pretty significantly. And so as we're able to shift the cost curve lower and lower, it pushes to the right the quantities that are required to break even or improve with traditional manufacturing. In other words, what might break even at 1,000 pieces, and then all of a sudden traditional manufacturing becomes much more inexpensive and the ideal manufacturing production technology. As you're able to lower the cost curve in additive manufacturing, that quantity could push out to 5,000 to 10,000 to potentially 100,000 pieces before you would plausibly make the switch to traditional manufacturing. So that shifting cost curve is something that's really exciting coming over the next decade. 3DO is already shifting the cost curve, and we see that happening now as we're competing with CNC machining and metal injection molding, and undoubtedly we'll only see that more and more. So let me just show you some quick examples of low volume cost calculations. We've got machining here where you might have a $2,500 tooling setup cost. With metal injection molding, this is an actual customer that spent $125,000 on the tool. And you can see the cost per piece in machining and metal injection molding here, where it's $40 per piece and $1,200 per piece. Whereas additive manufacturing, it's going to be relatively flat at $1,374 per piece. As we go to 1,000 pieces, you can see they're getting closer to competing, but still additive manufacturing is the least expensive option. You can imagine as you go to 10,000 pieces in this example, that the cost per piece would, in traditional manufacturing, would be actually lower than additive manufacturing, and that's when you would expect a customer to switch over. So the min break even in this example is 10,500 pieces. But again, coming back to lowering the cost curve, if we're able to make parts in additive manufacturing for $3.74 instead of for $13, all of a sudden the break even gets pushed out to 72,000 pieces. So as that cost curve gets shifted lower, additive manufacturing becomes more and more plausible in higher volume production. This is an interesting question as well. What happens when the piece price of additive manufacturing is the same as metal injection molding? You bring all the benefits of 3D printing to the customer without a lot of the upfront costs, without the minimum order quantities, with everything else we talked about in terms of benefits of 3D printing. So it's a pretty exciting opportunity.
Thank you for watching this webinar preview from 3DO. To view the full webinar, please click the link in the description below. If you'd like to learn more about 3DO, please visit our website at www.3deo.co.